Hey guys, my name is Chelsea and today we're going to be finding if two lines intersect. So, we have our first line, R of t, and then we have our second line, Rs of t. So our first step to see if they're even intersecting is to see if these lines are parallel to each other. So that's looking at if these two are multiples of each other. Now in this case, they're not. So that means we have to keep going to see if they're intersecting. So our next step is to see whether they're intersecting or skewed. So, because we have parallel checked off, there's three things you always need to check. So, our first step to going about the intersection or skew is to create all our parametric equations in a way. So, for R of t, we have x, y, and z equations, right? So this one's for the t, and this one will be for the s. So x, y, and z. So, as you probably know, the x equation is 0 plus 1t, so we just label it as t. Now, the y of t is going to be 1 plus t, and the z is going to be 1 plus 2t. Now, for the s equations, we're going to be doing 2 plus s, because it's s this time, not t, because we're looking at this equation. And we have 4s, and then we have 3 plus 4s. Now, our steps to going about this, next part, is by setting the x and y equations equal to each other and finding a value for t or s. And then we can plug that into the z equation, and if we were to get the same value for the z equation, that means that it's intersecting. Now, if these z values end up being skewed, then, and if it ends up being skewed, then these z values will be different, and we will not have a point of intersection. So our goal here is also to find a point of intersection if it is intersecting. So to start that, we have we set the x is equal, and we set the y is equal. 1 plus t equals 4s. So we've gotten to that, right? So all we have to do is plug in t into the right here. So because we have two equations, two unknowns, right? So how usually about doing this is solving for one and plugging it into the other. Just like that, right? And we end up getting 1 equals s, because 2 plus 1 is 3. 3 plus s equals 4s. So 3 equals 3s, which equals 1. So our next step is to then plug that back in to this equation to find t. So that means t equals 3. So just a side note, since these are not the same, that means that it is not a collision of two particles. Now, if they were the same and it was a collision, they could still be intersecting. It's just a side note of what you're actually finding here. So, you have these two values, right? So now, let's try plugging that into our z equation and see if we get the same value for each. So if we get the same value, that means they're going to be intersecting. So, z equals 1 plus 2 times 3. Which equals 7, right? For that one. And for this one, we have z equals 3 plus 4 times 1, which equals 7. So that means that these are intersecting, since they end up with the same value after setting the x and y as equal. That is always the process you should go through. And if you plug all this in, you should get an intersection point of 7 for the z, right? So let's plug the 1 back into these, or actually let's plug the 3 back into this equation. Because they're going to end up being the same, right? Because you set them equal. So, the T3 right there, and 3 plus 1 for this one is 4. So this is your point of intersection with the 2 lines being given. Thank you.